If you clicked on this video, it's probably because you want to learn reinforced concrete design using the software Prota Structure. And in this video, I'm going to show and tell you everything you need to know in reinforced concrete design, starting from when you receive your architectural plan from your architect. I will show you how to carry out structural framing, modeling, analysis, design, and detailing of your reinforced concrete structure. But everything you need to know in reinforced concrete design can be covered in a single video. So this will be a series of videos. But one thing I'm promising you is that this video will be more valuable than most of the paid courses out there. I'm Miracle Okeke Richard. Welcome to Sangos Engineering. And here I help you develop the required skills and enhance your knowledge to elevate your engineering career. So if this is what you want, you can quickly subscribe. This is the architectural plan we'll be working with, and here you'll get to learn so many things like the governing principle in column placement, in paneling, and also in beam arrangement. Here we have done the structural framing of this architectural plan, and we have that this is the ground floor and this is the first floor, and we have that this column and this column will terminate at the ground floor. Look at them, they are the ones on lead. They will terminate at the ground floor, they will not continue at the first floor. Why these are the new columns that will continue from the first floor? Reason why they will terminate at the ground floor is because they are causing obstruction to this first floor. And to these new columns that we have introduced, which are on magenta, they are called floating columns. Floating columns are columns that did not start from the foundation. So here you get to learn the governing principle both in floating columns, in paneling, and also in beam arrangement. You also get to understand how this is being modeled in Prota Structure, both the modeling, analysis phase, the design phase, and everything. Even the detailing. The detailing of this architectural plan will be done within the series of this video. So on getting your architectural plan for your architect, the first thing you do is to first of all copy out the architectural plan. The reason why we do copy out the architectural plan is because we'll be placing our column, our beam, and our slab. And two, during the placement, we'll be deleting some certain features of the architectural plan. So in case once we make mistake or we want to reference the original plan, we will still have the original plan. So that's the main reason why we normally copy out the architectural plan. So I'll zoom out. Once I zoom out, this is my architectural plan. So I'll copy out my architectural plan by highlighting it, and I'll now type CO. CO stands for copy. I'll click on enter. So I'll move this my architectural plan to how to place it here. So after copying out your architectural plan, the next thing that you have to do is to study your architectural plan. First, you study architectural plan. What's the building used for? Is it a residential building? Is it a commercial building? We have to know that if it's a residential building, the loading will be different from a commercial building because they will not be having the same dead load or life load applied to it. So we'll study the architectural building. Is it a residential building or is it a commercial building? Even if it's a residential building, you still study your architectural plan, because in a residential building where we'll be having gym area at story 1, you know that the loading of that gym area slab will not be the same with other slabs. So these are the reasons why we do study our architectural plan. Another reason we do study our architectural plan is to know that it has a basement, because if our architectural plan has a basement, we should know that retaining wall in the basement floor will be a concrete wall. So these are the reasons why we do study our architectural plan. So when you are to studying your architectural plan, and also another reason why I study architectural plan is to know whether there are cantilever at the story 1. So for example, look at this. These are toilet and bathroom. If you see, there is an offset backward, but if you go to story 1, if you can see, it's a straight line, so it's moving straight. That means we have a cantilever at story 1. This is the cantilever, this is the cantilever. So these are part of the reason why we do study our architectural plan. So after studying your architectural plan, next thing to do is to delete the things that are not necessary to us as a structural engineer. You know, some of the architectural features in a building is not really necessary to us. For example, share furniture, kitchen furnitures, all these things, they are not necessary to us as a structural engineer. So if your architectural plan contains all those things, you delete them because they are not necessary to us as a structural engineer. Another thing that are not necessary to us as a structural engineer is this dimension, this grid line, Don't worry, once we want to start, we'll create our own grid line. Then, and also this dimension, they are not necessary to us as a social engineer. So for that reason, I will delete them. So I'll just come, I'll highlight everything. I'll just highlight this. I'll just right click, then click on select similar. I'll click on select similar. Once I click on select similar, I will zoom out, hold my shift key, and then deselect the ones I don't want them to select. So I'll deselect this. So I'm left with only this. I'll click on E. E stands for erase. Enter. So if you can see now, my architectural plan is now clean, is now plain, like no obstruction and the rest. So I can easily work on this architectural plan. So I'll delete this section in because I don't also need it. So I would like to delete this because I don't think I will need it in my structural design. So after deleting the things that are not necessary to us as a structural engineer, the next thing is that we have to start placing our column. But first, before you place your column, you also have to place your, before you place, next thing is to start placing our columns and our grid line. But before you start placing your column and grid line, you first of all create a column and grid line layer. So let me type on, so to create this column and grid line layer, I'll type on layer. So you can easily type on layer, enter, or you locate layer on your menu bar. So I'll type on layer. So once this dialog box appear, I'll come and click on this new layer. So once I click on this new layer, this will appear. I would like to create a layer for grid line. So I'll just type grid. But since I'm doing a YouTube video, I'll just write grid U, which stands for, this U stands for YouTube. So I just want to, okay, let me just write grid YouTube. Sorry. So this is my grid line layer. So I'll like the color of my grid line layer to be, I'll like it to be this, yeah, to be this ash color. I'll click on OK. And I'll also like the line width to be at default. I'll also click on OK. So once I've created my grid line layer, next thing is to create my column layer. So to create my column layer, I'll say type column, but now I also like to type column YouTube because this is a YouTube video. So I like my column to be, let me just pick, let me pick this color. I'll click on OK, and I'll like the line width to be 0.5. Yeah, you can choose any line width of your choice, but me I want 0.5, and then I'll now close. So since I've done this, next thing that I will do now is to first of all create a grid line on this my architectural plan. So to create a grid line, I'll first of all type L, enter. L stands for enter. Since my auto key is not turned up, I can turn my auto key on from here, or I'll just type Ctrl F8. My auto key will turn up. So I'll just do a line from here to here. But remember, before it's okay, I'll do a line from here to here. The reason for this line is because we want to place our grid line along this block wall. So I use this line to locate the center of this block wall. But first, before I start placing my grid line, I'll come and select the grid line that I just created now, which is grid YouTube. So I'll look for where I have grid YouTube and select my grid line layer. So look at it here. So I'm already on layer grid YouTube. So with this, to create your grid line, you type SL. SL stands for construction line. Enter. Then now type H. H stands for horizontal. Enter. So this is the reason why I created this straight line, to locate the center of this block wall. So I'll press it here. I'll click on escape. I'll highlight this and I'll click on E. Enter, delete it because it's no longer useful to me. So I'm having this line running through here. So what I'll do now is that I'll copy this grid line, CO, enter, copy it from one of the block edges. I'll copy it from this point. I'll place it here. I'll just be placing it on all the horizontal walls. I'll also place, anywhere I have a horizontal wall, I'll place it. This is my horizontal wall. I'll place it here. I will also place it here. Just anywhere you're seeing a horizontal wall, you place it there. I'll also place it here. And I will also place it here. I'll also place it here. So sorry, Control Z stands for undo. I placed it wrongly. So I'll place it here. And I will also place it here. I will also place it here. Let me check again whether I still have any other horizontal wall that I've not yet placed my grid line on. So now I think I've placed grid line on all the horizontal walls. Okay, look at this. This is a wall. This is a wall. So I'll also place it here. So right now I think I've placed grid line on all the horizontal wall. I'll do escape. So since I've created the horizontal grid line, next thing is to create the vertical grid line. So I'll click on L, enter. L stands for line. I'll do this to locate the center of this line. I'll then do SL. SL stands for construction line, enter. I'll do V. V stands for vertical, enter. Then I'll place it at the center of this line that I just created. I'll highlight E, enter, to erase it. Then I'll copy this vertical grid line, CO. I'll copy from one of the wall edges, and then I'll be placing it on all my vertical walls. Anywhere I have vertical wall, I'll be placing it. Don't worry, the grid that are not necessary to us, later we will delete them during our structural framing. That's during our column placement and our beam and slab placement. We'll be deleting the we'll delete the grid lines that are not necessary to us. So I'll place it on all my vertical walls. So I have a vertical wall here. I have a vertical wall here. I'll have, okay, there, it has already placed here. I think, okay, I think I've placed in all my vertical walls. So with this now, I'll click on escape. If you can see, this is what we are having. So construction line is a line that runs throughout the whole AutoCAD interface. So I'll trim off all these lines. So to trim off all these lines, what I'll do, I'll click on rectangle. I'll just type REC, enter. I'll create a rectangle around this my architectural plan. So I'll create a rectangle around this my architectural plan. So this is what I want to have. Then I'll now highlight this rectangle. Then type TR, enter. Then I'll trim out this. Make sure that you highlight this rectangle, because if you don't highlight the rectangle, it will not really trim out everything. It will just trim out from here to here and stop here. That this architectural plan is blocking it. So I'll trim off this, and I'll also trim off this. I'll click on escape. Then I'll now come and highlight this my rectangle, E, enter, to erase it. So this is what I'm having now. This is my structural, this is my architectural plan, but I've already placed my grid line. Next thing is to start placing your column. So to place our column, I'll come here and select my column layer. So I save the column layer with column U2. So I'll locate it. I'll locate my column layer. So where is my, okay, this column, and I think column U2. So this is it. I'll click on it. So I'm on it now. So to create our column layer. So in this now, if you want to create column, I'll first of all type on rectangle REC to create a column. So I'll just draw a line here. What I'll do at, you click on at 225, comma 225. So the reason why I'm using 225 by 225 is because 225 by 225 is the minimum column size that you can use. But in ProtaStructure, if it fails, then we'll not increase it. But to save cost, we'll go with the minimum column size, which is 225 by 225. And this is when you are having 9 inches block wall. But in a case where someone is having 6 inches block wall, which is 150 millimeter block wall, what that person will do, he will use a column size of 150 by 450, or you can use a cone size of at least minimum 150 by 350, but don't go beyond 350. So with this now, my column size will be 225 by 225. I will then click on enter. So this is my column now. So what I'll do now, I'll copy this column. Okay, but one thing I want to let you know is that structural framing is totally dependent on the engineer. But the thing is that the engineer needs to follow the guiding principle and the guiding rules and principle doing his structural framing. For example, I'll tell you the guiding principle. For example, column spacing should not be more than 6 meters. Another example is that slab area should not be more than 30 meters square area. Another example is that slab should not be more than 30 meters square area, and also others. But don't worry, during the course of this video, you understand all the governing principle relating to structural framing. So I'll copy this. If I copy this, I'll do CO, enter. So if you are placing your column, you try and place them at wall intersections, or you place them at wall intersection, and also place them at, so to remove, you place them at wall intersections. So to remove this auto key, I can come and click on this place, or I'll do Ctrl F8 to remove the auto key. So I'll place a column here. I'll place it at all the walls intersection. So one of the governing principle on column placement is that your column spacing should not be more than 6 meters. Yes, your column spacing should not be more than 6 meters. Reason for this is because you know that the maximum moment of a simply supported beam is WL square over 8. So if you look at that formula, you see that moment is directly proportional to rent. So which is, that means, and to the rent in this formula is L square. And you know, once column spacing is more than 6 meters, for example, this is a column spacing. If this is more than 6 meters, is a beam that will connect this column to this column. So that means if column spacing should be more than 6 meters, what it implies that the beam is more than 6 meters, and maximum moment of a simply supported beam is WL square over 8. That means the more the rent, the more the moment. And what it implies is that the more the rent, the more the moment, and the more the reinforcement that you will be having. For example, if you go beyond 6 meters, you might be having, let me say, 5y16 or even 3y20 or even 2y25. So because we don't really want all this larger reinforcement or too much number of reinforcement, that's why we advise that you should limit your column spacing to be below 6 meters. It's not that your column spacing can't go above 6 meters. it can go, but it requires some different things. For example, if it goes above 6 meters, it might require that you might be using higher number of reinforcement or higher steel grade, or it might be required that you be increasing the depth of your beam. So, but since we just since this is a residential building, a duplex, so you just want to restrict ourselves to minimum column size of minimum column spacing of 6 meters. So I'll place a column here at wall intersections. Anywhere I'm having wall intersection, I'll place my column there. I'll also place my column here. I'll be placing my column here. So this height is on. I'll place a column here. I'll place a column here, and okay. Let me see. Then inside here, I'll place a column here. I'll also place a column here, and I'll also place a column here. Normally, I normally love placing column at the edges of my staircase, so it will be able to carry the stairs. So that's why I'm having these two columns here. So I also love to place a column here. Then okay, we need to have a column around here, so you can choose here or here. But if I choose this place, that means it's too close to this, so I won't like it. And if I choose here now, it's too close to this and it's too far away from this, so I would like to choose here. I would like to choose here. Then coming to this side, I would like to, okay, I can place it here. I can place it here or here. I can place it at this point or at this point, but I would like to place it at this point. Reason is because if I place it at this point, it will be too close to this. But if I place it at this point, I'll be having something like equal spacing. Look for let me escape. For example, if I place it here, it will be too close to this. For example, I might be having 2 meter here and I'll not be having 5 meter here. So I don't want that. I always like to have something of almost equal spacing. But if I place it here, I'll be having something like 3 meter, 3 meter. So for me, it's better because if I do 2 meter, if I do 2 meter, 5 meter, that means I'm having a bigger rent. I'm having more rent, and you know that once there is a more rent, once you have more rent, what it implies that you'll be having higher moment. So I always like to limit my moment. So I will escape. Then I would also like to place a column here. So let me just copy this. Then enter. I'll copy this. Then I'll place a column here. So with this now, I think we are through with our column placement. But don't worry. After we'll be checking whether we are obeying that principles of our column should not be more than 6 meters. One thing I forgot to tell is that if you are deleting things that are not necessary to us as a structural engineer, please don't delete your windows and your doors, because if you mistakenly delete your windows and your doors, you might mistakenly place a column at your window at one window position or at a door position. So if you are doing structural framing, don't delete windows or your door unless you are through with your column placement. So now we are through with our column placement. So let's check whether we are obeying that principle that minimum column size should not be more than 6 meters. So if we check from here to here, we are having 4.025. So for me is okay. So I'll leave it here. I want to go back to grid line. Where is my grid line? I want to go back to grid line here. So I'll click on it. Sorry. So I'm having 4.025 meter. So it's not more than 6 meters. So it's still okay for me. Then I'll shake from here to here. I'm having 2.225 meters. So for me it's okay. I'll click. Then shake from here to here. I'm having 4.025. For me is okay. It's not more than 6 meters and it's not too small for me. So I'll leave it like that. I'll click again. I'll shake from here to here. I'm having 3.225 meters. So for me it's okay. It's not more than 6 meters. I'm having 2.85 meters. So for me it's okay. Another thing in column placement is that if you are placing column, as a structural engineer, there are two things that are necessary to us as a structural engineer, which is one, safety. Safety is our priority. But then after safety is to save cost. If you check most of your buildings, if you check most of people that don't really have the knowledge of structural design, they might just come here and place a column here because they are seeing a block wall here. So if you are placing a column here, what you are just doing is that you are not being economical in your design, because these two columns will be able to carry the load coming from this slab. So if you are placing a column here, it's just that you are adding additional reinforcement. It's not that it's that useful. It's not that useful because these two columns will be able to carry it. So in your design, always put into consideration safety, always put into consideration safety and economy. So let's continue with our spacing shakement to know whether it's above 6 meters. So I'll shake from here to here. So I'm having 3.225. So all these ones they are okay. I'll also shake from, let me say, from here to here. I'm having 4 points is okay, 4.02. I'll also shake from, I'll shake from, sorry, I made a mistake. I'll shake from this point to this point. I'm having 4.025. There is no need of checking here because there's in the textural pan they place the column here. So even if it's more than, I must show, even if it's not more than or not, I must leave it because it is being placed for aesthetics. So I'll shake. I also click on this line. I'll shake from here to here. For me, it's not more than 6 meters, so it's okay. Definitely, this one will not. Definitely, this will not be more than 6 meters, and this too will not be more than 6 meters. So I've checked my columns and I've seen that they are not more than 6 meters. So since this one is not more than 6 meters, that means this is not more than 6 meters, this is not more than 6 meters, and this is not more than 6 meters. But we can decide to shake from here to here. So I'm having, let me shake from here to this point. I'm having 5.25. So it's not more than 6 meters. So for me, it's okay. So since I'm through checking whether my column is more than 6 meters or not, so I'll delete this dimension because really they are not really necessary. I just have it to I just dimension it to know whether my current spacing is more than 6 meters or not. So I'll delete the whole dimension because they're not useful to me. I'll click on A, enter. So after my column placement, the next thing, okay, yeah, let's shake something. You know, I told you about safety and economy. So since let's take whether our columns, whether they are too close or they are too far away from each other. So look at this. I'm seeing. So let me shake from here to here. I'm having 4.40. That's 4.4 meters. So for me, this 4.4 meter will be able to carry this road coming from this slab and this road coming from this side, and also this beam, because this beam will be acting as a point road on this beam. So since this is 4.4 meters, for me, I don't really see the need of this column. So in order to save cost, I'll delete this column because this is 4.4 meters, so it's too close. But another engineer can decide to leave it. Yeah, so it dependent on the engineer. It is dependent on the engineer. But me, I don't want to leave it. I want to remove it. So to save cost, because this is 4.4 meters and I know I said that it should not be more than 6 meters. So 4.4 meters is too small. Is too small. So it will be able to carry this load on the road coming from this side and the road coming from this side, and also this point road. So to save cost, I will remove this column. So let me also shake. Let me look at places that I have column jam packed. So look at this place. So let me also shake this area again. So I'll shake from here to here. So I'm having, oh, see, I'm having 3.375 meters. So I don't really see the need of this column. So to save cost, I'll remove it because I told you safety first, then economy second. So to save cost, I'll remove this column. Yeah, because it's too close, 3.375 meters. So it's too close. I'll just click on it, click on E, enter. So I'll delete it and also delete this dimension. So I'll shake from, anyway, again, I'm having a column jam packed. This one I would like to leave it. Okay, let me check the length between here to here. So I'm having from here to here. I'm having 5.25. But me, I would like to. I just want to leave this column. I don't know why, but I just feel like leaving the column. So I'll just leave this column. But another engineer can decide to remove it. Sha. So that's why I said social framing or general arrangement one is totally dependent on the engineer. So since I'm through with my column placement, the next thing is to carry out my beam placement or paneling. Let me do paneling. Paneling is placing your slab, determine how your slab will run. So in paneling, one thing you have to know is that paneling, your slab area should not be more than 30 meters square area. Reason is because once your slab area is more than 30 meters square area, we'll be having deflection on that slab. So to avoid that deflection, we'll limit our slab area to be less than 30 meters square area. So you have to take this, you have to note this principle. And two, don't forget, you can get this architectural plan on the description on my seller store. The link is at the description below. That this architectural plan, you can get it on my seller store and practice on your own, because practice make perfect. Practice make perfect. And one thing that comes with this architectural plan is that I've done the structural detailing for you. So in case you are doing, in case you are doing the modeling and everything, if you enter detailing and you need guide on anything, you can refer to this structural detailing and get what you want. So you can get the architectural CAD file of this house, of this duplex on my Stellar Saw, and to the link is on the description below, or I've pinned it on the comment section. So get and practice on your own. You know, practice makes perfect. And two, if you want to master anything, mastery comes from repetition. If you want to master anything, is by doing it again and again and again. So I'll click on this, I'll delete this. It's not necessary, I don't want it. So let's continue. So paneling, we say that paneling should not be more than 30 meter square area. So if your paneling should be more than 30 meter square area, what you do is that you either increase the depth from 150 to 175, or you break that panel with a beam. Don't worry, let's continue. I will show you the example. So I want here to here, I want this whole place to be one panel. So that's what I want. So since I want this whole place to be one panel, I'll delete this, I'll delete this E, enter. I will also delete this, and I will also delete this E, enter. I want this whole place to be one panel. I'll also delete this, I'll delete this setting. So I will just click on this point, I'll do ES. ES stands for extend. I'll click on this line, extend this line, then I'll come again, click on this line and click on this line, then I'll erase, then okay, I will highlight this column, then click on ES, which stands for extend. I will extend this line and also extend this line. So this is not my panel. So this is my first panel. I would also like the whole of this area to be my panel. So if I'm having this whole area to be my panel, I have to delete this block wall. So I'll just delete this, and also I will also delete this, and also delete this. I would like to delete this and undo E, enter. So I've deleted everything. So I'll click on this column, I'll do ES, enter. So I'll extend this line, extend this line, extend this line, but I've mistakenly deleted this line, so no problem. Let me just delete this one to E, enter. Then I'll just copy this line, CO, enter. Copy this line and then place it here. So I would also like here to be one panel again. So I'll delete everything here, and I'll also delete everything here. E, enter. Then I'll click on this column, I'll do ES, enter, which stands for extend. I'll extend, I'll extend, then I'll extend and I'll extend. So I'll escape, then do another ES, enter, extend this and extend this. So this is my first panel, second panel, and third panel. Remember what we said, our area should not be more than 30 meters square. So I'll shake the area from here to here. I'm having 4.02 meters. I'm shake from here to here. I'm having 3.22. So if you can see, let's just do 4 times, let me say 4 times 3. 4 times 3 is 12. So you see, even if it's 4 times 4, 16, it's not even up to 30 meters square area. So we are good to go. Let me also shake from here to here. So I'm having that from here to here is still 4.025. So you see the same thing is less than 30 meters square area. So I would like the whole of here to be one panel. So since I want the whole of here to be one panel, so delete I'll delete everything here. I like to delete everything here. I'll do E, enter. I will also click on this, click on this, click on this, do and also click on this, and also I like this E, enter. So I'll delete everything. So I like the whole of here to be one panel. Let me also delete these windows. So I'll click on E, enter. Then I'll click on this line, and on this line I'll do ES, enter. I'll extend this and also extend this. So I'll also, okay, let me delete this. Let me also delete these ones. Then I'll do E, enter. I'll click on this block wall, I'll do ES, enter. So I'll extend this and I'll also extend this. So let me also click on this block wall, ES, enter. I will extend this and I'll also extend this. So this is one panel, one panel, one panel, and this is another panel. So let's check what we have said. Is it more than 30 meters square area? So we are having here to be 2.62. So I'm having from here to here. So if you can see, it's not more than, so let me say 4 times 3 is 12. It's not still more than 30 meters square area. So we are good to go. So I would like it to be one panel again. So I'll delete this and I will also delete this. I'll click on E, enter. Then I'll click on this column ES to extend my line. I'll extend this. I'll also extend this, and I'll extend this and also extend this. So this is another panel. Then I would like this whole sitting room to be another panel. So I'll click on this, and also click on this, and I will click on this, and I will come here, click on this, and I will also come here, click on delete this, and also come and delete this. I'll click on E, enter. Hey, I made a mistake. Oh, sorry. So I'll click on E, enter to delete this. I also click on E, I also highlight this, and I also come and highlight this. E, enter to delete this. So this bar I also like to delete everything relating to this bar. So I'll delete this. I'll also delete this and also delete this E. Sorry, not R, E, enter. Then I would like to delete this E, enter. So this is, I want the whole of here to be one panel. So I'll click on this column, ES, enter. I will extend this and also extend this. I will extend this and also extend this. So I'm having, okay, then this E, enter. Then I'll do ES, enter. I will extend this and also extend this. Then I want a beam to run from here downward. So what I'll just do is that I'll click on this MA to match property. To match property, I'll match property of this to this. So this is what I'm having. Then I want to draw this line back. I'll stop it here. So what I'll do now, I'll click on this line. I'll click on this line and do ES, enter, and then extend this and extend this. So this is a sitting room. So let's check whether it is more than 30 meter square area. So we are doing from, let's say, from here to here 3.8, and we're having from here to here we're having 5 meters. So 5 times 3.8 is 19. So it's not more than 30 meter square area. So we are still good to go. So coming to this point, how are being run? Are we going to have a beam separate from here, then run like this, run like this? So to determine how this beam will run here, let's go to the second floor and know what we're having at the story one. Okay, so this is the point, like this point, look at it here. So if you see now a column, we're having wall load straight. So that means I would like this column, I would like this beam to run straight, so to be able to carry that wall load. These are part of the reason why I say you should study your architectural plan. So for that reason, I'll delete this, I'll delete this, and I'll also delete this, delete this, delete this. I'll just do like this. I will do like this, then delete this and delete this. Click on E, enter. So this is what I'm having now. Then let me click on, let me match property, MA, enter. This is the window. This is down my beam. I'll click on this one, ES, enter. So I will run it through. So at this point now, a beam will run from here, here, and here. So let me just match property, I'll match the property, match property, match property, match property, match property, match property. So right now we are through with our column placement, and we are through with our social framing. So let me delete all these things because they are not necessary to us. I'll also delete this E, enter. So coming to the, okay, look at, coming to this point now, let's study this case. We have a column placed here. So let me check out the dimension, let me check the dimension, because I would like to show you something from just this. So I'm having 2.225 here. Let me repeat this. I'm having from here to here, I'm having 5.25. So if you look at this critically, I'm having 2.225 and 5.225. So this beam that is 5.225 is carrying a point road here. Look at, it's carrying a point road here. But don't worry, before I explain this thing, this is a staircase, Abi. So me, I normally like at the end of a staircase, let a beam, like, this will be a void. So I like a beam to carry this slab here. So to introduce that beam, I'll just come here and do MA to match property. I'll match here the property, then I'll now offset OFF. I'll offset 225 from this point. So this is a beam. Yes, so this is my beam now. So this beam now, if you look now, we don't have any grid line on this beam. So I'll place a grid line here. I'll just do arrow, enter. I'll do from here, since my auto key is not turned on, I'll do Control F8 to turn on my auto key. So I'll turn on my auto key. So let me also extend it to this point. So I'll then do CO, enter. I'll copy this grid, allocate the center. So this is it. Then I will now delete this E, enter. So I've placed a grid line on this. The reason why I placed a grid line along this beam is because so I'll be able to dictate this beam in ProtaStructure. So that's why I placed a grid line here. So let's continue what we are saying before. So if you look at now, we're having 2.225 here and 5.25, and this beam now that is 5.25 is carrying a point road, and two, is carrying a point road. That point road is this beam, and two, this beam now is carrying a road from this slab, and transferring that load to this beam and to this column. So a point road from this beam, and also a point road from this beam. Not just that the length is 5.2 meters, it's kind of a point road from this beam and from this beam. So me, and look at this one now, this one is just 2.225 meters, no point road, just kind of slab. So for that reason, I would like to move this CO, enter, because if I allow this thing to be like this, in ProtaStructure, I'll be having higher reinforcement because it's not just that the length is much, it's carrying point road. So I like to move this because this is just 2.225, and I like to make the length to be almost equal so that the load will be distributed. So I like to move this to this point. Yeah, so for that reason, I'll now delete this E, enter. Yes, sorry, I will not delete this E, enter. So I like to have this, I like this column to be placed here so that if okay, let's now check the our new length, our new column spacing. So I'm having from here to here, which, sorry, I made a mistake, I not place it well. So let me repeat it. So I'm having from here to here, which is 4.025, and also from here to here, which is 3. So if you see, the is almost of equal length now. And two, this one is not really carrying a point road, this one is just carrying a small point road, but there is a point road carrying a beam carrying, let me say, small load of a slab, that's carrying a small slab. So for me, this is okay instead of having a column placed here. So these are the part of the things you as a structural engineer need to put into consideration while doing your structural framing. So right now we are through with everything concerning our structural framing. So since we are through, next thing to do is to superimpose. To superimpose, what do you mean by superimpose? Superimpose means, superimpose is just the process whereby we copy these whole columns, we copy this whole column, that the whole column that is here, and place it on this story one, to know whether we'll be having any column popping off on the slab on getting to story one. Don't worry, you see what we mean by superimposing. So we'll just highlight this, we'll just right click on select similar. So click on select similar and now do C O, enter. If you are copying, make sure you copy from staircase, sorry, C O, enter. If you are copying, make sure you copy from staircase, because staircase is a point, is a staircase will be the same both as story one, story two, to the number of stories that we're having. So I'll copy from staircase and I will place it, and I will place it here. So this is what we'll be having. So if you look at now, this column will stop at ground floor, this one too will stop at ground floor, because this one is popping up, is showing on the room. This one will stop at ground floor, it will block this door, and this will stop at ground floor. So let me just turn them to red, so that if I see them, I'll know they are stopping at the ground floor. This one will not stop on the ground floor because it's still inside the wall. So this one too, this one will stop at the ground floor. Yes, this one will stop at the ground floor. So let me change the color to red. So since I've gotten since I've gotten one that's up and the ground floor, that means this column still has to continue. This column still has to continue. So what I'll do now is that I'll copy this column, C O, enter. So I'll place a new column here. Like this one will stop at the ground floor, then this one will now continue as story one. I'll also place a new column here, and coming to this point. Okay, let me just coming to this point, C O, enter. I'll copy this and place a new column here. So these are the new column that will emerge from story one. So I'll highlight it because there are new column that will emerge from story one. So I would like to change the color to magenta so that once I'm seeing it, I'll know that this one will stop at the ground floor and then this one will continue at story one. So coming to this one will start at ground floor, but if you check our architectural plan, you see this column do not continue. It did not continue. So this is a part of the reason why we say we should study your architectural plan. And to don't forget, you need to practice because practice makes perfect. To repetition is to master anything is through repetition. So if you want to master the art of structural design, it's through repetition. I know how I got good in structural design. I know how I was practicing on daily basis. So it's better that you just set out, let me say, 30 minutes set aside for structural design than just in a week you have, let me say, 3 hours, every Saturday set out for structural design. So it's better you be practicing daily because practice makes perfect. Even if it's 30 minutes per day, make sure you do something on structural design. Even if it's not structural design, learn a new thing or watch a video on structural design. It will help increase your knowledge. So this is what we're having now. So next thing I would like to do now is, for example, we have seen that we'll be having cantilevers on our second floor, sorry, on our story one. So but we don't really know where those cantilevers are here. So what I will do for easily modeling, or so for easy to model this in easily on ProtaStructure, I will highlight the boundaries of all this of this story one. Don't worry, once I'm through now, you understand what I'm doing. Once I'm through, you really understand what I'm doing. I just want to highlight the whole boundary of this story one. Reason is just to know where I'm having cantilever. Region is just to know the places that I'll be having cantilever. So I want to highlight the boundaries. Don't worry, you understand. Once I'm through with this now, you understand what I mean by highlighting boundaries. So and I'll be having this. So what I'll do, I'll just do CO to copy. So I'll copy this, I'll place it here. Then I'll do ES. ES stands for extend. I'll extend this to match up, extend this to match up, extend this to match up. Why is not match? Extend this, extend this, extend this. I'll also extend this, and also don't worry, we're almost through with this video. I'll also extend this. That's we're almost through with the structural framing. I'll also take this back. I like to match property MA, enter. So I'm having this, I'm also having this. So this is it now. So I would like to make this thing a block element. I'll just click on block element. Then I'm just type wall. Let me just save it with, hey, I made a mistake. Let me just save it with wall. I'll just click on okay. Okay, sorry. Okay, it's not a block element. Block element, what it means is just to make it a one member, to make it one member. So I'll just click on the CO and enter. So I'll copy this. I'll copy it. We know that this is the staircase region. So I'll copy from this staircase region and place it here. So you can okay. I want to turn the color. I want to change the color of this to. Let me change the color to. Let me say this color. Okay, let's just see it like that. So this is what we're having. So if you can see now, that means we're having cantilever at this point, at this point, and at this point, and we're also having cantilever at this point and at this point. Reason why I created this cantilever is so that we can easily model it on ProtaStructure. Don't worry, once we get to ProtaStructure, you see the reason, and you see the reason for this cantilever. You see how easy it will be for us to model it. So at this point, I would like to delete the grid lines that are not necessary to us, or the grid lines that we did not use. So we did not use this. Okay, sorry, we use this one. We use this grid line. We use this grid line. We did not use this. We used this. We did not use it. No, we did not use it. We did not use this grid line. We did not use this grid line. We used and we did not use this. We used. So I think on E, enter. So at this point now, we are through with our drawing. So what to do now is to save this drawing at origin. Reason for saving this drawing at origin is because in ProtaStructure only recognize files saved at origin. So we'll save this drawing at origin. So how are we going to locate our origin? You just type L. L stands for line, enter. I'll do 0, 0, enter. So let me just paste it here. Let me just paste this right here. So this is my origin. This is my origin. So what I'll do now? Is that I'll come here now and copy this drawing. CO, enter. I want to save it at origin. So I'll copy this drawing. And I'll also I'll save it here. So this is my origin. I'll click on E, enter. Then to save it at origin, I'll click on W. W stands, okay, first of all, I'll highlight this, click on W. W stands for web block. That's to save only this file or only this drawing. I'll click on enter. Then I'll come and click here and choose millimeter. Then I'll now click on this three dots. So I'll allow it to open. I would like to save this on my desktop, and ProtaStructure only recognize DSX file, DSF file. So I'll click on DSF file. Then I will name it. I want to name it with YouTube. Let me just select it YouTube. Let me just say YouTube 1. Let me just have it with YouTube 1. So I want to name it with this. So I'll click on save. Then I'll now click on OK. So with this now, we have saved our DSX file. So let me minimize. We save this on our desktop. So let me minimize to locate it on my desktop. So this is it on my desktop. So let me click on it again. Let me double click on it. So if you double click on it, it will open. So if it will open, you'll be seeing it like this. But don't panic. What you just need to do is just to turn on your line width. You just type line. You just click on line width. Just click on display line width. So as you can see, it's out now. So this is it. So this is the DSF file that we saved. If you can see, it is DSF file. So we have come to the end of this video. In part 2, we'll open this DSF file in ProtaStructure and we'll model it, and we'll also do our design. But don't forget, you can get the CAD file of this architectural plan in the description below, or it is pinned at the comment section. And don't also forget, it comes with the structural detailing, like I've done the structural detailing. So once you are after your design and everything, once you enter detailing, you can easily reference it once you make any mistake for correction and the rest. So the CAD file comes with the architectural plan and the structural detailing.